So this is normalizing data. You know what is meant by normalizing. So normalizing is when your range of the data is very big, you try to write the data between 0 and 1. So normalizing means you are compressing the data between 0 and 1. So typically, you have to apply some mathematical models. You will be applying mean, you will be applying the average, and then divide each value by the average. So that is going to be the process of normalization. And you divide each element by the mean, you will get the normalized values. And the final answer will be same as your original matrix. The size is going to be same. So normalizing matrices where we use this predominantly, we use normalization of matrices in image processing. So when the range of the image is going to be very, very large, when you want to normalize that, the value becomes always less than 1. So see here, you have a beautiful X matrix. It is a 4 cross 3 matrix. Create a row vector column average that holds the mean value of each column of X. Okay, so I'm going to find the average value of each column of X. So you have to column average equal to mean of X. See here the column average. We'll verify 3 plus 9 plus 2 plus 5. 3 plus 9 is 3 plus 6 is 9. 9 plus 2 is 11. 11 plus 5 is 16. 16 by 4 is 4. 2, 6, 8, 12. 12 by 4, 3. 6, 7, 8. 8 by 4, 2. So you got the column average. So if you use the command mean of X, it will find the column average by default only. It will not find the row average. Please understand it clearly. Create a column vector row sum that holds the sum of each row of X. So now we are going to find the sum of each row of X. See here, you have to use this command, sum of X comma 2. So this 2 is specifically given to identify the rows and not column. If you give sum of X means it will find the column sum only. So if you say sum of X comma 2, it means that I'm going to find the row sum. So 3 plus 2 plus 2, 7. 6 plus 4 plus 4, 14. 2 plus 2 plus 1, 5. 5 plus 4 plus 1, 10. Okay. Now create a matrix Y by subtracting the mean of each column of X from the column. So my Y will be, I'm going to subtract mean of each column of X from that column. So I'm going to subtract the X from its mean. So what I'll be using? X minus mean of X. Or I'm going to X minus mean of X. Mean of X, we have the already variable column average, right? So when I'm subtracting the mean value of X from the column average. So if I execute this command, see here, I'm subtracting it and I'm shifting all the values from the mean. Normalize X by dividing each row by its sum. Store the result in the matrix Z. So Z will be equal to divide X by each row by its sum. So X by row sum. So I'm dividing each value of X by the row sum. And the matrix dimensions must agree. The row sum is also matrix, right? So how will I do that? I have to use dot command. So whenever you are going to divide the two things, you have to use dot command. And X matrix now you see will be normalized. Normalized means all the value will be lying between 0 and 1. See here, all the values of X are lying between 0 and 1. And what I'm doing, I am dividing each element by its row sum. And dividing each element by its row sum. That's what I'm doing using the thing. So this is, you can even divide by the standard deviation. You can use the function normalize of X, which will do the normalizing you want in the range 0 to 1. So such functions are available in MATLAB. Using the help section, you can get the documentation of all these things. So now see here, I have loaded the electricity data. Use the days per month that contains the number of days in each month to normalize the data from total thing. So I'm going to normalize the data using this days per month into the normalizing means you have to divide, right? So that the division is done here. But division, you have to be careful. You have to use dot slash. Usage equal to, I'm normalizing the value usage by with days per month. So usage equal to usage per days per month. If you run it as it is, you will get an error. And the error will clearly say the matrix dimensions are not agreeing. So what you should do, you have to keep a dot before slash. When you divide the matrices, you will be using dot slash. That is for the matching the rows and columns of both the variables which you are, for which you are going to divide. This is all about normalizing data. You can find row, you can find the column sum, you can find the row sum, and when you subtract, you can normalize your data.